stylus not working, sorry. Okay. Okay, good. So in this case, then you continue. So with this, then you can draw a right angle triangle out with opposite 1 and then hypotenuse 2. Right?
Okay, yeah.
Right? So in this case, you can actually start to draw the opposite one because your O is 1, right? And then the hypotenuse is 2. Okay? And then this is the angle X. Does it make sense so far? Then after that, with this, I think you can use Pythagoras theorem. Okay? So that's why I say when you use Tokaso, right? Actually, most of the time, the Pythagoras theorem is used in conjunction with this Tokaso. Okay? Then what do you get for this? Square root 3, right?
Yeah.
Okay? Square root 3, right? Okay? Then after that, they ask for tangent x. So tangent x is what? O over a, right? So what's your O?
1 over
Is 1 over your square root 3. But what?
rationalize.
But no. Before doing rationalization, you need to ask yourself, your x is in what region? Okay? So in a way, right, over here, they give you that x is in the 0 to 180. So in fact, right, this 0 to 180, right, is not very clear. Because 0 to 180, right, it can be the A, it can be the S also. So in a way, right, they need to be, in fact, this range should be more specific. You understand me? So let's say they tell you, oh, instead of 0 to 180, let's say they narrow the range further. Maybe 90 to 180. So that means it's the S region. I mean the angle is in the S region. So in a way, right, your this tangent X should be negative. Why? Because the angle is in the what region?
It's in the S.
It's the S region, right?
So must be.
So you just write this down. Okay, so you just write down, okay, the angle is actually in this region. So you want me to find tangent X? My value should be negative. So first thing first is you go and do the magnitude first. Magnitude is like the value first.
Yeah.
Then after that, then you consider the sign.
It's positive.
Is it whether it's positive or negative? So in this case, it's negative. Why? Because it's in the tangent is. I mean, they want to find tangent for the in the sine quadrant, right? So in sine quadrant, tangent is negative. So that's why your answer is this. Of course, then you go ahead and do the rationalization. So far so good? Then you can continue to do the cosine. So cosine x is a over h, right? So your a is square root 3, your h is 2, right? So once again, consider the sign. Is it positive or negative? So this is negative, right? Okay, so next time when you get a value, you know whether your value is correct or not. At least when it comes to the sign. You understand me? Okay. So without the range, right? You no. Without the range, let's say you do this without the range, you can't do it because it can be this, it can be that. But once you specify the range is in the S quadrant, then these two will be negative. Okay. So what if I give you the range is instead of 90 to 180, I give you 0 to 180, 0 to 90. How will this the sign? How will the sign be different? So actually it's A region, right? Not the S region already, right? So tangent is positive, cosine is positive. So you know how it works now?
Yeah.
Okay? You know how it works now? So first thing is the magnitude. I think there's no problem with the magnitude because magnitude comes from the Tokaso. Right? And then the sign comes from Depends on the range. You understand? Okay, good. Then we continue to do the cotangent, and then of course subsequently. So cotangent. Okay, by the way, right? Cotangent is actually 1 over tangent.
Yeah.
And then of course the cosecant is equal to 1 over sine. And then the secant is actually 1 over cosine. So all you need to do is you just need to 1 over tangent. Just now 1 over tangent. So the range is 90 to 180. Right? So therefore we just 1 over tangent, which is 1 over this.
Negative G.
Okay? So I mean you just go ahead and simplify it, okay? Then 1 over sine is given as 1 over 2, so it's 1 over 2. And then this is 1 over this thing. So far so good? Okay? So when you do without the calculator, you should use this approach. Actually, it's very clear cut from the question. The question will say, please get tangent x, or the exact value of tangent x, the exact value of cosine. So when it comes to exact value, you have to do it this way. Are you clear? Are you clear? Okay, so exact value, you can think of it this way, plus the special angle we talked about last week. So let's say if they give you sine 150, then you kind of like, you need to use the special angle. Do you know how to see whether the angles are special or not? You remember the two triangles I asked you to memorize? One is the isosceles triangle.
Oh.
The other one is the right angle triangle with 30 and 60. So 90. So then you label this is 1, this is 1. Why this is 1, this has to be 1? Because isosceles, yeah. And then this has to be square root 2. And if this is 1, so if this is 1, this is 2, then it's square root 3. So how do you identify special angle is, actually these are all special angles. Let me get it into a highlighter. 45, 45, 30, 60, 90. These are special angles. Okay? Then of course this 150, right, is also special because it's the combination of two special angles. Okay? Okay? So if you get sine, let's say you get sine, I don't know, maybe 75. Then you have to think of, hey, which two can help me get 75? So it's
But then, like,
sine 30 plus the 45. Yes. Yeah. Yes.
okay.
Okay.
So this one you cannot use just calculator.
Wait. Exact value means this approach.
So
Special angle approach or Tokaso approach.
Okay.
Clear? Clear?
So there's like 3 approaches.
Without calculator 2. Okay? With calculator 1. Alright? Okay? So at yeah, so the question will be quite clear about which one you need to use.
Okay.
Alright?
Could you give like example of that?
No, the one you asked me over WhatsApp. You solve it with the calculator, right? Then I said, good attempt, but sorry, you are not supposed to use this approach.
Okay.
You remember that?
Yeah.
Yeah. So just look at that. Actually, this question is similar to the one I discussed. Oh, but over here they give you cosine.
Oh.
Our example over here is sine, right? So they give you cosine A equals to negative 3 over 5.
Oh, need to use the
Okay.
so
Then they give you sine B is equal to negative 20 over 29. Okay, and they tell you both angle are reflex angle, so you know the range already. What is a reflex angle? So A and B in which quadrant? In fact, they tell you the reflex angle, so which quadrant?
I don't know
so okay, you just look. Cosine negative, sine negative. So A S T C. Which one? Cosine has to be negative.
Then it will be
Cosine negative means these two out, right?
yeah,
Sine negative, this one also out.
yeah.
So it has to be
T.
yes. So that's how you identify
So
the T. Then I think you solve the puzzle of the sign. Whether later on you will get positive or negative. The magnitude we need to make use of.
the magnitude you make use of the torque.
Yes. But by finding the region, we nail the sign down already. Right?
So when they give
Yep.
like these two,
Mm-hmm. So just write A and E is they are in the T region quadrant. You don't have to write it down, but it's good to write it down. Okay, and how you get these two are in the T quadrant, so you just try to draw it out. Okay, so you just start with the Tokaso. So this is your A, and then cosine is A over H, right? A is 5, H is 3. Sorry, A over H is 5. Then this has to be so 4, right? Yeah. And then your B is, and then O, right? O is 20. This is 29, right? Can you help me out with the calculator? Just give me in square root format, like if it's not a nice number.
Okay.
So 29 square minus 20 square, then square root this.
21.
Oh, okay, good. Okay, so with this, I think it's pretty easy already. This will give you the sign. This will give you the magnitude. Right? Okay. So in a way, you look they say find the exact value, right? You see, the question is very clear cut on. Find the exact value. Two approach.
Exact value of A.
Yeah.
And B. Right?
Yeah, no problem. Whenever you are asked to find the exact value in trigonometry, you have two approaches. Well, number one, you think of this Tokaso plus the region. Then the other one is special angle. And I don't think over here you need to use special angle because you are not given any angle. So when you use the special angle, is when they give you sine 100 and maybe 30. And then you see this 130, like is it a combination of two special angles? Right?
Okay.
You understand or not? Understand the kind of question they will ask you? Then with this, then they ask for tangent A.
Tangent A.
Yeah, the first question is tangent A.
Oh, then it's just 3.
Yeah, so you tangent A.
No,
Yeah,
sorry.
so tangent A. So you get the magnitude down. I mean, you get the magnitude first. So it's O over A, 4 over 3. Then you decide the sign. It's positive. Okay, so just get it into a mixed number. So that's the answer. Then what else? Cosine A plus B. So this one you need to make use of the formula. Okay, because A plus B, you don't have the value of A plus B, but somehow you can use the formula, which is, wait, it's not cosine A then plus cosine B. No, you have to look up the formula sheet. Then you get cosine A cosine B plus sine A sine B. If I'm not wrong, it's minus or plus. I cannot remember. So formula. And formula, yeah.
Oh, actually.
I think did I put it here last week?
Yes.
Okay, please. Yep. By the way, I don't need to look at the formula. You need to look at the formula to get yourself familiar with the formula. So it's a good practice for you to look up the formula.
Oh, it's plus. It's cosine, right?
Cosine, yes.
It's negative.
No, cosine plus, right? Actually, it's minus. So it's minus. Plus in the bracket. Plus in the bracket, minus when you expand it out. So it's pretty easy already. Cosine A, you are given the cosine A, right?
Oh, you just like substitute.
Yep. So it's minus 3 over 5.
Well, that's kind of okay.
So minus 3 over 5. Cosine B, you have to work it out. You have to work it out. Cosine B, you have to work it out.
Is
Okay, so cosine B is A over H, which is A over H. Decide what's the sign.
is negative.
Why?
Because it's cosine B, right? It's not in the
Why
tangent.
negative? Yeah, correct. So you just negative 21 over 29 times,
Times,
then minus. Sine A, are you given sine A? No, you need to work it out.
is 4 over 5. Is that
O over H, and then it's positive, negative.
negative?
Why?
Because it's not in the tangent.
Curve is in the tangent, yes, good. So it's negative 4 over 5. Then sine B, I think is given, which is minus 20, 29. And then you just use your calculator and get it. Okay? So I think this question is pretty easy. Yeah. Then of course, after that is this 90 minus B. So 90 minus B, that means they are looking for this. This is your 90 minus B.
Oh,
Okay, so tangent this one is, so where's tangent? So you are asked to look at this angle. So the opposite is 21.
oh,
The A is 20.
yeah,
And then what's the sign? Positive.
positive.
So then you just, this is one approach. Another approach is you times in. You times in.
There's one here, right? This one.
Yes. Yeah. Okay. So yeah. Then last one. What's the last one? The last one is sine A over 2. Okay, so sine A over 2.
0.58.
Okay, so it's sine. Wait, in a way it's half A lah. Huh? So if you look at it, right, they say, oh, I want half of this. How?
Half of.
How? That means
you
basically
just
they want this.
divide the sign by 2. That's just like
What?
the opposite by 2.
Can you do that? Can you do that?
It's a suggestion.
Yep. So one approach is that. So basically you are telling me, okay, so since this
And you want to cut the.
this is 4, right? This is 3, right? This is 5, right? So you want half of it, right? So half of it, are you sure half of it will surely cut like 2? I mean the angle is half, but are you sure that the height is also half? I'm not sure.
I'm also not sure.
Yeah. So if you are not sure, then you can't just assume, right? So then this is a good attempt to look at it. But if you can't prove it, you can't use it. Right? So probably you want to look at this.
Oh, is it this one? They instead of 2 we just 0.5.
So can you see this? Cosine 2A? Or can you see sine 2A? Okay? So sine 2A is equal to 2 cosine A and cosine A. So let me just use this first. I will tell you why I use this. So this approach this approach does not work. Does not work. Unless you prove it to me. So let's not use this. So can you read the sine 2A that one to me? So sine 2A is equal to 2 sine A cosine A. Good. So if you look at this, right? So if I give you sine A, right? Isn't it 2 sine A over 2 cosine A over 2? Because this is 2A, then this is A and A. This is A, so it has to be A over 2 and A over 2. Right? So this is the formula given. Hello? This is the formula given. This is the I kind of like use the formula and then I derive the another formula myself. You understand? And over here I can't use this because I still have a cosine A over 2, which I don't want. I only want sine A over 2. So I can't use this. Okay? Then probably I can use this. Cosine 2A and this 1 minus, right? You read this to me. So cosine 2A is equal to?
2 cosine square.
No, I want the middle one. So over here, right, cosine 2A is equal to this, is or equal to this, or equal to this. So I pick the middle one, 1 minus.
Oh, 1 minus sine 2 sine square A.
2 sine square A, right?
Mm.
Okay, so why I pick this one? Because this one give me just sine. Because over here I got sine and cosine. I don't want sine and cosine because the question wants what? Sine A over 2.
Mm.
So I just want sine. I just want the sine only. Then the formula sheet, right, give me this, and then it happened to be have sine only. So let me just do a bit of transformation. So 1 minus cosine 2a is equal to 2 sine square a, right? So basically you are given this formula, you can try to derive another one, then continue. So divide by 2,
Isn't it minus?
then divide by
2
2,
sine?
no, 1 minus. Two is equal to 3 minus 1. So how do you get 1? 3 minus 2.
Yeah.
That's why I pick
Oh,
1
okay,
minus. Okay? So I do the minus, and then I divide by 2, so this 2 is gone. This 2 is gone. Okay? So you get sine square a, right?
Mm.
And then of course sine square a. Okay? Then done. Because if sine square a is this, sine square a over 2 is 1 minus cosine a over 2. This a, I divide by 2. Actually the relationship is, if this is a, right, this has to be 2a. If this is a over 2, this has to be a.
Okay.
And then in fact, if I give you this sine square, maybe a over 4, can you guess what is this?
2 over 4A.
The question mark.
Half
Yes. You understand or not?
A.
Okay? So the formula given in the formula sheet is this. But you can make use of the formula given and try to derive or extrapolate.
Okay.
Okay? So therefore I can use this one. Okay? So what I need to do is I just need to do 1 minus cosine a over 2. Cosine a I think I have. Okay, 1 minus this, minus 0.6. Can you help me out? 3 over 5. And then sine square, right?
4 over 5.
What's that?
4 over 5.
Okay, good. I want the final answer, okay?
Yeah. Final.
Okay? And then this is equal to sine square a over 2, right? So I want sine a over 2 only. So plus minus square root 4 over 5.
Oh, so
Yep.
cosine E, where you get it from? Like cosine E over 2.
No, I know that I need to pick this one.
Yeah.
Yeah. So cosine a given in the question is negative 3 over 5.
Oh. Okay.
That's why I asked you to give me 4 over 5. 4 over 5 is this thing. So 4 over 5 is actually equal to sine square a over 2, right?
Okay.
The question only wants sine, not sine square. So I just square root plus minus.
Oh. Okay.
Okay? Okay? Can? Okay? So you might not get this the last part immediately. I'm fine with that. But at least you get the ABC. If part D somehow is more difficult, it's fine. Because we are not aiming for 100 or so. But of course, as we talk more, then you will get used to it. Okay? So next time when you get this what a over 2 or what 2a, then you better think of this to use. So what you need to think of is actually the formula given is a formula given, but you can actually derive the formula.
Okay.
Okay? Usually this like you make use of the formula and derive it, right? I call it extrapolate lah. Extrapolate means if I tell you today the rain is 20, then tomorrow is 40, what do you think of the third day? 60, right? You extrapolate, right? Based on the trend, right? So something like that. Okay? The formula given is this, but I look at the trend, okay, I come out with another formula myself. So this kind of question is usually the hardest one. So if you don't get it, it's fine. Like, we are not aiming for 100 anyway. Right? Okay, so that's how you solve the last part. Okay? Which is without using calculator. Okay? Which is that whole page you asked me in your last lesson. You remember?
Yeah.
Remember? Okay? I did not use your school approach. Okay? Your school approach is actually okay. Last lesson I talked about the school approach and my approach. The school approach, right, I find it very confusing.
Yeah.
At the start. Okay? So that's why I try to come up with my approach. You nail down the magnitude and then you decide your sign. Whether it's plus minus. Okay? So as you do this kind of question using my approach often enough, then you will start to understand your school approach. That's why I don't want to start with your school approach first. I want to start with my approach. Then as you go along, and then you will start to understand your school approach. Okay? Okay, good. Next. Okay, the last part of trigonometry, right, is actually this.
It's actually this.
Huh?
Yeah.
The question you asked me, and I say skip.
Oh, yeah. Sorry. Oh my god. What is this? Trigonometry, so.
Okay? So this question, right? Okay, you need to know cotangent, cosecant, and then secant, right? You know primary colors and secondary colors. So secondary colors come from primary colors, right?
Wait, I feel like you said this thing before.
So this one is also like
Secondary.
this one is like the secondary trigonometry terms, and then they come from like
You know, I
the
have a question.
the primary
Color.
so kind of like primary trigonometry term.
I have a question.
But never mind. Actually, tangent is also a secondary trigonometry term. Actually, it derives from the sine over cosine. Just for your understanding. Okay? So actually, the sine and cosine, right, you cannot break down further. They are the primary term already. Okay, this is one thing you need to know. Okay? Your question?
Why they need to name like cotangent, then cosecant, then secant?
Then why we need to have rainbow color? Can't we just live with black and white?
Yeah.
We can, right? We can, right? But life is not so colorful already. Black and white.
Just show 1 over tangent, 1 over sine. Why need to make life so confusing? These mathematicians.
Okay, by the way, no. In fact, for this question, we are not going to solve it using this approach.
Oh.
Okay?
Okay.
But I just want to tell you, cotangent, cosecant, secant, right? They are secondary. Okay, in my words, they are called secondary trigonometry terms. So they derive from the primary trigonometry term, which is sine and cosine. Okay, but we are not going to solve this question using this. Using this. Okay. Okay. For this, you have to remember this one. The first three. Can you see cosecant square is actually this 1 plus cotangent square, something like that. Okay? So, can I ask you, cotangent square is equal to what? Using that.
Cotangent doesn't say.
Cosecant square is equal to this. So,
cotangent. Okay, I see that.
so cotangent square A is equal to this one minus
cosecant
one, right?
minus 1, yeah.
Okay. So you use cosecant square minus 1. So basically you just replace your this cotangent with this using that. They call it identity. Identity means today you are this, tomorrow you are also you are Lakshan, then tomorrow you are also Lakshan, but probably tomorrow you dress differently. But but it's the same person. So the same thing. So this one, if you want to dress this differently, then you get 1 plus 14 square A. Okay? You get it? So it's the same thing lah, like cotangent is equal to 1 over tangent. So today you want to dress, you want it to be cotangent, you cotangent. Then tomorrow you just want to dress it differently. It's just like fraction is half, percentage is 50%, decimal is 0.5. Understand? That's how you can easily grasp this concept. Okay, so cotangent you can get it into this format. Then after that, I think it's the quite easy one already. I hope this looks familiar to you, because it's going to be a quadratic equation. So you get this into U.
Let cosecant
Correct.
x equal
Correct. So this will be U, right? Then this one will be U, and then you just solve for U,
U.
which I'm not going to talk about.
Okay, can.
Okay?
I don't need to know that.
Good. So that's how you so that's all. That's all for trigonometry. Okay? So trigonometry, last lesson we covered three
The basic
three
one.
topics of three concepts of trigonometry.
The
Then
graph,
today is about what? Today is about without calculator.
Yeah.
Without calculator. And then
Cosecant, cotangent.
make use of here.
Yeah.
Okay? Class. Here. Okay?
So make use of all these.
Yes.
Formula.
Actually we have we have used
Everything. Yeah.
yes. It depends on the situations.
Thank God they never ask us to memorize all this.
As you do often
You
enough,
memorize,
then somehow it's just in your
Memorize.
Okay. All right. So of course life is not so simple, but I think we have covered enough. We have covered enough for you to start
Understand.
understand and start working on some of the questions given already.
Okay.
Okay. So in a way, right? If I give you a rough summary, is solve sine by calculator. Okay. It's a very standard approach, very standard. Step 1, step 2, step 3. Then of course you solve sine without. Okay. Okay. So this is the exact value.
So this one is like exact value. Then the
So this one you need to use Tokaso.
the triangle hypotenuse.
And this one also you can use the special angle,
Yeah. So
right?
when they ask you to solve
yep.
x equal half, sine x equal half,
Mhm, mhm.
and they never say exact value, then you can use calculator.
Actually, both should give you the same answers. But if you use calculator, I'm afraid that you will get non-exact.
Okay.
So between non-exact and exact, which one is more accurate?
Exact.
Exactly. So in a way, right, if they give you sine x equal to half, right, so it's better to use this approach. Because let's say if I give like your answer is 3.14 and the exact value is pi, you use pi or you use 3.14? I prefer pi, yes. So sometimes you need to make this kind of decision.
Okay.
But usually the question will tell you whether they want exact value or just want to solve with a calculator. Okay. With calculator means with calculator to help you. Without calculator means
Show more.
show your steps. Okay. Then of course the graph.
Oh yeah. So if they say
Uh-huh.
solve like sine x equals half without calculator,
This
so
one?
that one use exact.
This
value.
one?
Okay. Because sometimes they say without calculator mean like
show,
like
yes.
precise like steps.
Yeah, steps, yes. Exactly. Okay. Then graph. Then of course today we use the identities. We use the identities. Okay.
Yeah.
Yeah. Okay. Actually, the identity we need some you need more practice,
Yeah.
because the identities, right, make use of all the formulas on the formula sheet, and basically identity is like from this format to that format, then how you somehow change it and then let's say they can easily give you, like just now they give you what, sine A over 2, right? No one can tell sine A over 2 is actually that one and then still need to, no one can tell. There is no sine A over 2. How I did the sine A over 2 just now? I make use of one of them and then I derive the formula myself.
Oh, you use this one, right?
I use that one, but that one I still need to derive.
Yeah.
I use that one as a start only. Remember? I use that one as a start. I use this one as a start. I still have to derive until I know I need to use that. Get it? Okay, so yeah, so for the identity you need to okay, in fact for the graph, right, actually I have thought about it. So I took some time to graph the final version out, but actually you can speed up a lot. Okay, but it's pretty hard to tell not face to face. Okay, so I'm going to, can you give me just any graph? Y equals to
5x.
no, there's no 5x. Like a is 5, then you want to, okay, play with sine. So what about 2x plus 2? Okay, so I graph this fast. The first thing is you get the what? You get the so the period out first. For sine is 360 divided by the b, right? And the b in this case is 2, right? Can you see? So I know that 180 I need to see one cycle. Okay? So never mind. I still start with the normal curve first. Okay? So the normal curve for sine is this, right?
Then go down,
Right? This is y equal to sine x, right? So now I know that instead of 360, 180 I need to one cycle already. Right? So the original one, the basic curve is 361 cycle.
So you have to squeeze all that.
No need to squeeze. Just change it to 180. And then you know that this is 90. And then you know that this is 45. You know that this is 135. You are done with the cycle already. And then 5, right? Initially here is 1, right? Here initially this is minus 1, right? This is 1, right? Okay, so you times 5.
-5.
Done. Now you only need to take care of the 2. Plus 2, right? So this one will go to 2.
7.
This one will go to 7. So this one will go to 2. Then this one will go to minus 3. Then this one will go to 2. So the final one is this. Okay? Is it much faster? I think so.
You just like erase all the value then put in.
什么? What do you mean by erase all the value and put in?
Like, you know, like the 90, 180, 360, you just erase it. Then
Yep, yes,
put
yes,
in the value. Then
yes,
after that,
yes.
-1, 1, you just change
Yes.
5.
But if they want you to show the 360, so basically you show another cycle.
How they ask that?
Let's say they say you must draw from 0 to 360. I have drawn until 180 ma. So you just repeat this. Right? So that means your this, so the original one no need, this one no need already. So you just repeat this over here. Understand? Yeah. So because I remember you asked, hey, most likely during exams I don't have so much time to show the intermediate step. Okay, so how to speed up? So I think this is one way to speed up. But of course you need to know the how. Actually, you need to start with the fundamental concept first. Okay, I shouldn't teach you the shortcut. If I teach you the shortcut, you don't know how to get it out. Wow. So next time when you get into problems, you don't know the fundamentals, you don't understand. You just don't understand. right? But now I see how you can speed up when it comes to graphing the sine, cosine, and tangent graph. Okay, so yep, we have done trigonometry.
Finish already.
Yep, we have done trigonometry. Okay, so you have any trigonometry question from here, which you tried to attempt but failed
I
to
didn't
do?
even like go past page 2, then you told me to do your homework. So
So my homework, the trigonometry, I more or less, I think I have. These are all the things already for trigonometry. Then probably that question on the linear law, the one I asked you, whether you know what it is or not, and then your school,
in the
yeah, you,
the
yeah,
photo I sent you.
yeah,
Okay.
and your school is supposed to teach you in August, early August, but it didn't happen.
Yeah.
Yeah, so
Because it's as if right, they want us to learn everything in like one day, be super pro at it, next day go next chapter.
okay, linear law. Okay, so linear law, you know what's the meaning of linear?
Or go straight.
Yeah, linear law is y equals to mx plus c. Okay, this is a linear equation. Okay, but
Cool.
in this case, A math, right? Okay, the y is a big Y. The gradient is still the gradient. X is the big X. The y-intercept is still the y-intercept.
What do you mean
That's the only difference.
X?
So I'm going to tell you what is big Y, big X compared to, okay, this is the set 1 one. This is set 1. Okay, small y, small x. So now, sec 3 and sec 4 linear law, right, is big, yeah, big Y and big
But
X.
Emacs is still the same as sec 1.
But the concept is the same. Okay, but over here you learn big Y and big X. So it means this big Y, right, is no longer Y. This big X, right, is no longer X. It can be other than X. Okay, so let's look at the question. I saw one question from here.
I think everything. Not what my choice say. She said that doing O level, every chapter had like one question.
Yep, yes. Yep. Okay, so over here, right, I hope you see. Can you take a photo and then just
Send it to you.
drop airdrop to my Mac.
Okay. Oh yeah, by the way, do you know like what yesterday was Teachers Day or something?
Yeah.
Yeah. So happy Teachers Day.
Okay, nice. Actually, you know, these days I go to Bukit Merah Secondary School, right? Yeah. So, yeah, they did the celebration on Thursday. Then Friday,
Friday holiday.
yeah, Friday is.
For us also same thing.
Yes.
So how?
And then just I receive chocolate, you know those. Actually, I would rather receive cash. Sorry.
Okay. I mean, if you give cash,
Like let's say the student want to give me a chocolate. I don't know, because you need money to buy chocolate, right?
yeah, then
Does it make sense?
give the money.
Yeah, so please give me the money instead.
Okay, noted. Next time I'll send you money.
Oh, these days, right? Okay, if you want to be more subtle, you don't be so like if you give cash, then it's a bit not subtle enough, right?
No, actually, if I give cash, I feel like I'm sorry, I'm too lazy to go buy something. You go buy yourself something.
Oh, that okay. That's a very good perspective.
Yeah.
That's a very good perspective. But what I'm trying to tell you is that sometimes we need to follow some social norms. So social norms tells us we shouldn't give cash. We should give gift. So let's say $50 gift, then you want to buy something and then But these days, right, I really think that people prefer cash or cash equivalent than an object
Like
or an
gift
item.
card or something.
Okay, so the best one is the gift card, yes, like Amazon voucher or NTUC voucher.
Or Razer voucher.
Yeah. So basically, you just give $50 voucher, and then because you don't want to be so, I mean, you need to follow some social norms. You don't give cash. Cash is too, I don't know, cash is so,
Straight.
yeah, so
straightforward.
it's too blunt already. It's just too blunt.
Yeah.
So give a voucher.
Every time right, whenever you win a competition,
Yeah.
they give this useless $10 popular voucher.
$10 is not useless. $10 you can go and buy a French ruler
Sure.
plus the what the two set.
No, you listen to me.
Yeah.
Because the thing is right, like you're in the middle of the school term, we already have everything we need from popular.
Mm.
You know, we already bought all the extra book we need to practice.
Yeah.
What do we need from popular? Done.
Wait. You can you are given a $10 popular voucher, right? Very good. Next time what? Christmas exchange with another person. Sorry, let me just answer call. Hello? 哎，是。对。对。嗯。嗯。嗯。嗯。嗯。嗯。嗯，可以。嗯。嗯，对对，几点到？好，可以，好，see you，拜拜。好。Now you know, if you have the Christmas gift exchange or whatever, just wait until then.
Okay, what do you mean by that?
So you have let's say you have a $20 popular voucher, right? Just wrap this $20 popular voucher as a gift, then you just exchange with someone else. So most likely you will receive a mark, then the person who receive your gift is a $20 popular voucher. So you kind of like you recycle your this voucher that you don't like.
You know what one of my teacher told me?
Yeah.
You know you go popular right,
Yeah.
there's this candy section right?
Yeah.
Yeah. So
Okay. Or you can actually buy books, you know.
yeah, but I don't really read books that much.
Oh, too busy with schoolwork, is it?
Yeah.
Okay.
And leader stuff.
Okay.
It's
Okay,
just
good.
so- Actually, I have a question for you to ask you.
About this?
No, about just normal.
Mm.
Do you speak Cantonese or
I speak
Chinese?
Cantonese, both, but I speak Cantonese most of the time, with my family members. Okay. Outside, so actually Cantonese is a dialect, so it's not spoken widely in Singapore. Then that's why, yeah. So I speak Mandarin also.
Because whenever I hear Cantonese and Chinese, it all sounds similar.
No, not at all. I think this is a big perception. It's just like Chinese. They think that your Tamil and Hindi they sound the same. Actually, no.
Yeah.
Vastly different. Am I not right? Right? But they just assume that hey, you guys just speak.
That's why I asked her.
Actually, the same. It's the same idea. Okay, Tamil and Hindi, right? They are very very different. So Mandarin and Cantonese, they are also very different. Okay, handwriting wise, same, but the speech is very different. Okay, good. So can you see this question over here is linear law. Why? Because can you see that the vertical axis is this one, and then the horizontal axis is this x square. So in a way, this is your big X, this is your big Y. So if you follow the big Y is equal to m big X plus C, right? Okay. So your big Y is 1 over square root Y. Then m is m, big X is x squared plus the C. Done. How do you find m?
Take the two.
Yeah, the gradient, right? How do you find gradient? So gradient is basically the y1 minus y2 over x1 minus x2. But in this case, you should use the big Y. Okay? So the big Y in this case, so basically you just read on. So this is your 4 and 1/3, then this is your 1 and 1/4. So 1/3 minus 1/4 over 4 minus 1. So you will get, can you help me out with a calculator? Yes.
One over 36.
1 over 36. So what's the C? C if you get, okay. So the C, I think you need to
Sub in.
hold on. So
What's the question?
that's for okay. Hold on. We need to get the C out first. Anyway, so you sub in, no? So sub in is 1 over square root y is equal to 1 over 36 x squared plus c, right?
Mm.
So c happens when
You sub
your
in
x
the
squared equals to 0, right? X squared is equal to 0, not x.
Okay.
Because we are talking about big X. Like I said, we are talking about big X here.
Mm.
Okay? So your x squared when it's 0, so that's where they cut. So you just get your x squared into 0. Just, this whole thing is 0. Okay, so.
But don't we like usually
Mm-hmm.
take a point,
Mm-hmm.
coordinate, then sub in the coordinate in to find the constancy?
Yes, yes, I'm doing that. Okay, so there are two ways to find y-intercept. One way is the meaning of y-intercept is where it cut the y-axis when x where the horizontal is 0. Actually, I'm using that approach. Your approach is you try to sub in the value, which is 1 and 1/4. Okay, so 1 and 1/4 in this case, right? X squared is 1. X squared is actually what? So when you use, let's say I use your approach, you sub in the value. So the x squared in this case is what?
1.
Let me just pick one point. So by the way, the 1 here is represent what x squared,
Mm.
and the 1/4 here is it represent the 1 over square root y.
Mm.
Bear in mind. So that this is the difference from the set 1 y equals to mx plus c. That one is a small y small x. In this case, the big y and big x.
Yeah, because
So in a way, right, this the 1/4 is the big y. Okay, that's why I use capital letter. This x is the big x, and in this case, the big x is x squared. In this case, the big y is 1 over square 1 over square root y. Yes. So 1 and 1/4. So you just replace this with 1, and then you replace this with 1/4. So can you help me out? Minus 1 over 36 is equal to c. Yes. So that's how you get your y-intercept.
2 over 9.
2 over 9. Okay, good. So therefore, this is the okay,
Mm.
the linear equation that fit this curve. And if ask you to find the exact value of y when x equal to 3, okay, done. So x equal to 3, so this will be 3. So just solve it accordingly. So can you help me out with the right hand side?
17 over 36. 1 over.
So just 1 over this,
So
right?
just multiply.
Then you square it, right?
Mm.
Okay, I will leave it to you. Okay, no need. Okay, that's how you get your this. Sorry. That's how you get your this 4 marks. Okay, so for linear law, this is the idea. Big X and big Y.
It's actually not that hard.
Not that hard. Of course, this is just a warm up question. Warm up
Oh,
question.
great.
Okay, warm up question. And by the way, I'm holding your hands throughout. It's always the case. It's always the case, right?
Let's continue.
Okay, so the case. Okay, so now comes the real stuff. Okay. So over here they say you get, okay, they give you the x value and the y value, and then they say x and y are related by equation, but in this format. Okay.
Mm.
So in this format, right? So somehow you need to get this format into big Y over m big X plus C. Let me choose another color. Okay, does it work if I use this? Never mind. Okay, so you need to get into this y equals to mx plus c. and the y is big Y, and the x is big X. Okay, so if you look at this, right, actually they give you the hint. What is the big Y? What is the big X? They ask you to plot this against this, right? So can I ask you, plot this against this? Which one is the vertical? Which one is the horizontal, by the way?
Oh, the plot y over is against
Okay. So you are telling me this is big Y, this is big X. So that's the that's the convention.
wait, let me think.
Mm.
Against. Oh no, that is opposite. Change. It's x.
This is X, this is Y.
Yeah. Right.
I think should be plot A versus B. So A is the dependent, then B is the independent. So B is the horizontal, yes. So the this one is the vertical. This one is the horizontal. Okay. So the first one is the
But I mean, they already said y there.
no, nothing to do with that. Like I say, like your big Y can be anything. It doesn't mean that you have a Y there is a big Y. No. But anyway, so the convention is plot third against third. The first one is the vertical. Then the one at the behind is the horizontal. Okay, so with this, I think you can start to see you're supposed to plot this against this. And somehow you need to get this into this format. Or this format, in a way. So get this into the graph, it will be this format. Get this into this, then somehow you need to convert. Transform. Okay, so we'll take a brief break, then we come back and talk about how to convert. Okay, from this to that. Y equals to m x plus c.
Isn't it?
It's actually quite easy. But anyway,
like
never mind.
AX, isn't